Yeah, ready?
When time's losing, we're losing touch and fading away. We'll still be right.
And I'm right here. All right, there's a polynomial. The degree is 0. By terms, it's a monomial. There's only one term. Now, this is really x to the 0. Anything to the 0 power is 1. It's really 3 times 1. It's 3. Oh, that chart came out really small, didn't it? All right. So this is a degree of 1. Monomial. Momial? Momial. That's the French way to spell monomial. What's that? Oh. Oh, yeah. You're right. They have constant in there. Thank you. I would probably accept either one. Degree is 2, binomial. This one is 3. This is a trinomial. Now that's as far as we go as far as naming them by terms. We don't go quadnomial. There's no such thing as that. This is just a polynomial after 3. And then finally, oh, wait, not degree. Okay, I need to refocus. Constant, linear. I was thinking just fundamental theorem of algebra, how many answers there are. I apologize. This is a quadratic. Now I feel silly. This is a cubic. And this is a quartic. And this is as far as we go with 5 quintic. There you go. My apologies. I knew it couldn't have been that easy, just writing the numbers down. I feel silly now. All right, let's move on. Let's get away from that. Simplify. There's a couple ways to do this one. You could do, how about we raise everything to the 4th power? It's going to be x to the 40, y to the 12th, x to the 16th, y to the 28th. This is one possibility. And then 16 of these are going to cancel out, and you're left with 24 on top. So x to the 24th is on top. Now there's more y's on the bottom, so that's y to the 16th power. Now what you could do is simplify first. You could say, well, this is x to the 6th over y to the 4th, and that's x to the 20, well, it's not x. That's x to the 24th over y to the 16th, but you end up with the exact same answer. So you can simplify on the inside first and then raise everything to the 4th. That's an option. Solve. This factors into x plus 2, x squared minus 2x plus, not 16, I was going to write 16, plus 4. That is the sum of 2 cubes, right up here, sum of 2 cubes. Same, opposite, always plus. That's x to the 3rd. This right here is 2 to the 3rd. So there's your a and b. So now we're solving though. So x equals -2. That's this piece right here. The other two solutions to the sum and difference of 2 cubes will always be imaginary. So we have x equals 2 plus or minus square root b squared minus 4 times 1 times 4. All over 2 times 1, quadratic formula. 2 plus or minus square root of 4 minus 16 is -12. That is, 12 is 4 times 3. So that's going to be 2 plus or minus 2i square root of 3 over 2. Square root of 4 is 2. 2 is on the outside, but 3 stays on the inside. You can divide everybody by 2. So our final answer, 1 plus or minus I squared of 3. We divide everybody by 2. Any questions on that one? That's the sum of two cubes. This one is just our normal two parentheses, but this has to be x squared. That has to be x squared in order to get x to the fourth. So they both have to be x squareds. Factors of negative 12 that add to negative 1 are negative 4 and plus 3. We can keep factoring this one. X minus 2, x plus 2, but there's no sum of two squares. That one does not factor because the answers are imaginary. So x equals plus or minus 2. That's what we get with the first two sets of parentheses. But then this other one, let's set that equal to 0. X squared equals negative 3 plus or minus I square root of 3. There's the other two answers. So the other one, you can just use square roots to solve that. This next one is 4 terms. When you have 4 terms, you group the first two, group the second two, but if there's a minus in the middle, you have to change that last sign. That's kind of the little extra rule. But we can take an x squared out of the first, and we can take a 4 out of the second. Now, if you can factor by grouping, the two parentheses, those have to be exactly the same. If they're not, you can't factor by grouping. It doesn't work. So we have x squared minus 4 times x minus 5 equals 0. The x squared and the 4 come together. Those two parentheses come together to make 1. This factors into x minus 2, x plus 2, x minus 5 equals 0. You can keep factoring this one. So in the end, the answer is plus or minus 2 and 5. So 2 for the first, negative 2 for the second, 5 for the last one. Any questions on that one? Factor by grouping. That's when you have 4 terms. That's what tells me by grouping. Use synthetic substitution to determine the remainder P of A of this right here. So what they're telling you is if you plug negative 2 into that function right there, the remainder is what you would get if you plug that value in. So 1, 1, negative 2, negative 3, 1. All the powers are represented. And yesterday I was having a little fun with missing the zeros by pointing the finger of shame at some people. Just trying to joke around a little bit. But trying to make you remember the zeros. We have the powers 4, 3, 2, 1, 0. We have all of them. 1, negative 2, negative 1, 2, 0, 0, negative 3, 6, 7. Now we're used to seeing a 0 as a remainder because we want zeros, but we don't need a 0 here. What we're saying is f of negative 2 is equal to 7. If I plug negative 2 into that function, you would get 7. Kind of an interesting little theorem. Use the rational root theorem to list all possible rational roots of the equation. Now it doesn't say solve. So the possible rational roots are 1, 2, 3, 4, 6, 12. Those are the possibilities. Those are the only possibilities. So if it says use the rational root theorem to list all possible rational roots of the equation, don't solve it. It does not ask you to solve. You are done. Move on. Don't waste your time because then you're going to run out of time for the test. This next question says use the graph of the polynomial function at the right to determine the rational zeros of the function. List the rational zeros below. So the rational zeros of this function appear to be negative 2 and 3. Negative 2 and 3, because the zeros are where the graph crosses the x-axis. It's what makes y 0. That's it. That's all you do on that one. It's no harder than that. Divide using long division. 3x minus 2, that's on the outside. Feels like we did this a long time ago, doesn't it? Hopefully the numbers don't get too big. we have to multiply 3x times x squared to get 3x to the third. So we just worry about the first one. What do we multiply to get that? Then whatever happens after that, we just deal with it. Now when we take x squared times negative 2, we get negative 2x squared. And we always minus. Always minus. 1 minus negative 2, that's 3. Now we need just x. X times 3x is 3x squared. Now whatever happens after that, we deal with it. X times negative 2 is negative 2x. And we're subtracting. Now that's negative 36x. Negative 38 plus 2, minus minus, that's plus. Negative 36x. And then we have plus 25. Now we take, I need minus 12. 12 times 3 is 36. So negative 36x, and then that's going to be plus 24. And we always minus. Negative 12 times negative 2, that's a positive 24. When we minus, we end up with a remainder of 1. So the answer, x squared plus x minus 12 with a remainder of 1. And that's the fractional part, and we put that over 3x minus 2. That's what I'll expect to see on the test. Any questions on that one, on long division? Just got to be careful with the signs. If you end up with super huge numbers on that, you're probably doing something wrong. We're not going to give you really huge numbers to do those. Using the given factor, find all the zeros of each function. So the first 0 is negative 3. Ooh, this is next to the 4. All right. 1, 2, negative 1, 4, negative 6. Now we're told this is a 0, so we better get 0 as a remainder. 1, negative 3, negative 1, 3, 2, negative 6, that's negative 2. That is, oh, look at that, 6, 0. Awesome. Well, now the possible rationals of this next one are either plus or minus 1 or plus or minus 2. So there's not a whole lot of options. We got to find one more to get to an x squared. So let's try 1. We'll see if that works. 1, 1, 0, 0, 2, 2. Aha, it worked. I didn't know if that one was going to work. I really didn't. I didn't do this one beforehand, so I just tried the first one, 1. Well, now we got to an x squared. X squared plus 0x plus 2. We want to set that equal to 0. Minus 2. Square root. Oh, why did it bounce back up? There we go. X equals plus or minus I squared of 2. And x equals, what was the first one? Negative 3, thank you. Negative 3, x equals 1. There's the 4 answers we needed. We had to find 2 to get it to an x squared. Find all the zeros of each function. So the possible rational roots, plus or minus 1, 2, 3, and 6. Over here it's just plus or minus 1, plus or minus 2, but that changes things. That's going to include a few more. So the possible rational roots are 1, 2, 3, and 6. That's all of those over 1. Those are possibilities. And then all of those over 2, and those create a few more, like 1/2. 2 halves is 1, already have that. 3 halves is a new one. And 6 over 2 is 3, already have that. So it just really creates a couple more new ones. It doesn't repeat, it doesn't create 4 new ones. All right, now we got to try some. 1, 2, 9, 7, negative 6. 2, 2, 11, 11, 18. That's not looking very promising. 18, 12. Did not work. These can be tedious. Let's try negative 1. 2, 9, 7, negative 6. I only have to find 1. It's an x to the third. 2, negative 2, 7, negative 7, 0, 0. Dang it, negative 6. All right, well, let's keep going. 2. I told you I wouldn't make one of them at the very end. It's got to happen fairly soon. Told you I wouldn't do that. 13, 26. What is that? Why am I? This is 19, isn't it? Yeah, it's 19. 38 and 32. I think -2 works. I think -2 is it. 2, 9, 7, -6. All right, we're going to bring down the 2. -4, 5. -10, -3. Yep, that's it, because that's 6. Got it. Well, now we're left with 2x squared plus 5x minus 3. I think this factors. So you have 2x and x. I need a positive 5. So plus 3 minus 1, because then I'll get positive 6, a minus 1, that's a positive 5. So x equals 1/2, x equals -3, and I can't forget the 1 that's up in the synthetic division. There's the 3 answers. Yeah.
Like multiple?
Say that again.
Like multiple?
Yeah, it should. Yep.